Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing with the techniques and applications for definite integration. So for this lesson of definite integration, we'll have two other examples, and these two are the examples. So the first example we have is integral from 0 to 2, integral from 0 to square root 4 minus x squared bracket, x squared plus y squared bracket, dy dx. Well, for our second example, we have double integration. X squared plus y squared is smaller or equals to 1, x dx dy. Okay, so for our first example over here, we already know the boundaries, so you may think that we can straight away solve it, but why don't we first tell what our area bounded over here is, since we already know the boundaries. So apparently for this part, if you didn't realize, when y is equals to, so apparently y is smaller or equals to until 0, okay. So y is equals to 4 minus x squared, so y squared will be equals to 4 minus x squared, and thus x squared plus y squared is equals to 4, which is 2 squared. And now that we have gotten this, you should know how to draw it. So apparently, according to what we have over here, is supposedly a circle, right? But hold on, if you realize, so when you square for this part, even if the square root is positive or negative, you will end up getting a positive anyways. But over here, when you trace it back for this part, we only have the positive part, and then it's for y, so you only have you only have a semicircle. In fact, it is the top half of the semicircle since it is positive. And if you want the bottom half of the semicircle, then you need a negative square root 4 minus x squared. So here we have 2, negative 2, and 2. But so over here, this is our what we have for y, right? Then what about for x? For x, on the other hand, and here we've already shown it's from 0 to 2, so we are only going to have 0 to 2, so our area bounded over here would just be this quarter circle, this quadrant. Well, what about the other quadrant? Well, it is 0 to 2 and not negative 2 to 2, so you wouldn't need this. So over here for this part, we'll have only the top semicircle because that over here is positive, and we'll only have a quadrant because that it is from 0 to 2. So over here, just take a quick look. Okay. So apparently over here, you may be wondering how you're supposed to solve. Well, sure, you can straight away integrate it if you want, but over here, we're going to change it to polar coordinates, because as you can see for this part, it's clearly here a quadrant over here, which you can use the polar coordinates. So when we use the polar coordinates, x equals to r cosine theta, y equals to r sine theta. And thus, for this part, what will our range be? So our range, so here we have r squared cosine square theta plus r squared sine square theta. And remember, when you change it to the dr d theta, it's going to become r d theta in order to get the same area. Okay, so for this part over here, what we're going to have is, so for our r, it's pretty obvious for this part, it's going to be from 0 to 2 all the way. So r is from 0 to 2. Well, for our theta, we have this quadrant. So since it's this quadrant, it will be from 0 to pi over 2. So 0 to pi. Now what do we have for this pi? We can basically take out the r square, right? And we'll end up with a cosine square theta plus sine square theta. But what's so special about that? Well, cosine square theta plus sine square theta is equals to 1. So you're just going to end up with this part and this r squared times r, ending up with the r cubed dr. So over here the theta is basically useless because therefore this part had the cosine and the sine. When both of them, when cosine square plus sine square add together, it will end up with a 1. And so we can basically integrate for both theta and r already. So for theta, it's from 0 to pi over 2, while for r, it's going to be 1 over 4 r to the power of 4 from 0 to 2. And now that we have gotten this part, we can get, so when we substitute the 0 inside, we are going to get 0, which we can ignore basically. Same with this 0 over here. So what we're going to have is pi over 2 times 1 over 4 times 2 to the power of 4. And what this equals to, so 2 to the power of 4 over here, supposedly 2 to the power of 3. And this 4 is basically 2 squared, so you're just ending up with a 2. And thus our answer is 2 pi. Okay. Alright, so for this part, that will be for our first example. Well, sure, you may think that, okay, well, we can also use Cartesian coordinates, but in this scenario, polar coordinate is the easier method to do. Okay. Now over here we're going to move on to our next example. So for our next example, what we have here is double integration x squared plus y squared is smaller or equals to 1 x dx dy. So for our second example, we can also draw the area bounded for it. So what we have here will be whoops, that's a little bit too small. Give me a sec. So over here what we have for this part is x squared plus y squared is smaller or equals to 1. So we are going to have a full circle over here with our radius as 1. Although these two may look the same size, but they are just for different questions, so they are different. So over here we have 1, negative 1, negative 1, and 1. So the area bounded will just become this whole circle. Okay? Alright. Now that we know what the area bounded is and all, well, you can straight up Well, you can use polar coordinates once again. Well, it is a circle after all. So it's going to end up with a r. So we use this part, the x equals to r cosine theta. So over here become r cosine theta dr d theta. But what is the range for r? Obviously, the range for r is basically 0 to 1. Then what about our range for theta? For theta, since it's a full circle, so it's going to end up with 0 to 2 pi. And once again, when you separate these two, you realize that we can integrate these two already separately, somewhat like this. And now we integrate the both of them, so the first one will end up with the sine theta from 0 to 2 pi. Well, for this, you're going to integrate. So apparently for this part, for the r, when you sub in 0, it becomes 0, so you can ignore it. While for the other one, you sub in 1, it's going to end up with a half. While for the sine, if you sub in 0, you get 0, so ignore it. When you sub in 2 pi, you will still get a 0. So no matter, well, because that over here, no matter which boundary you substitute inside for this part, it's going to be a 0. So in the end, it's because these two are times together, so they're going to end up with a 0 anyways. So over here, that's mainly it for these two examples. So for both of these examples, we changed the Cartesian coordinates to polar coordinates. The thing is that, well, you can choose to use Cartesian coordinates for these questions, but you're just making it a lot harder by doing the Cartesian coordinates. So mainly what we use for this part is just the sine square theta plus cosine square theta equals to 1, and that's pretty much it, other than changing Cartesian to polar coordinates. So that'll be all for this lesson. Last but not least, thank you for your watching.